I forget. But otherwise, Patrick is going to be talking to us today about lithium ion batteries. So I'll turn it over to you, Patrick.
Great. Thank you for the introduction, Emily. Hi, everyone. My name is Patrick. And today, I'm going to be talking to you all about just some basic science and like info about lithium-ion batteries, why they're important, what they're being used for, and why they're a pretty big deal nowadays. So before we get started with like any of like the sciencey stuff, I just wanted to sort of introduce myself. So I was born here in the States. I was born in Glastonbury, Connecticut. It's a suburban town outside of Hartford. I graduated from my undergrad with a bachelor's in material science from Cornell University. And right now I'm a first year PhD student in material science and engineering here at Northwestern. And one of the things that I like to do outside of like studies and like my research is I also like to play the viola. I play in the Philharmonia Orchestra here at Northwestern, and I really enjoy classical music and playing music. So sort of get started with lithium-ion batteries and a discussion about them. I wanted to first of all talk about some of the like context about like why we care about lithium-ion batteries. So one of the biggest applications of lithium-ion batteries are electric vehicles right now. Now, you may, and there's a good chance you've heard of electric vehicles becoming a thing recently in the last few years, or maybe not. But one of my favorite statistics that shows the recent trend in terms of the growth of electric vehicles is that the Super Bowl ads. So this headline that I just have put up here shows that in 2018 there were 12 car ads in the Super Bowl. And of that, none of them featured any sort of electric vehicle. But this year, 7 of the 9 ads actually were featuring electric vehicles. And so not just for like Tesla, which is an electric vehicle maker you may have heard about, a lot of car companies are making their own electric vehicles nowadays. And the growth in that side of like the automobile industry is quite large. And this is like a big deal, not just like for cars, but also for like things like energy storage. So on a national level, the Biden administration, the government and the DOE have recently invested $3 billion to help strengthen the US's investment into advanced batteries, both for electric vehicles as well as for energy storage. And this is really important, and batteries are very important for sustainability and particularly for renewable energy. And this movement towards moving towards renewable energy is also being seen in like local communities here in Chicago and in Evanston. For instance, the city of Evanston has committed to this plan they refer to the Climate Action Resilience Plan. And this is basically committed to reaching 100% renewable energy by 2030, and to also be able to achieve carbon-free by 2050, and also zero waste is sort of the terminology that they're using by 2050. And lithium-ion batteries have this big impact for sustainability, but they also have a huge application in consumer electronics. And so lithium-ion batteries can be found in all sorts of devices nowadays. This is anything from the newest smartphone or any phone to laptops, computers, to even like pacemakers or like small medical devices. There are lots of applications that need these small little devices to supply energy, and lithium-ion batteries are one of the most popular choices for those nowadays. And then sort of as like, in addition to like all that stuff about sustainability, I think one thing to look at when we talk about renewable energy is to notice that renewable energy has actually become incredibly cheap over the last decade. So the graph here basically shows the price of electricity for different sources from 2009 to 2019. And the key things to show are solar, which is this orange line, and then the onshore wind, which is this blue line. And both of these prices have dropped dramatically in 2019, and that trend has continued over the last few years. And at this point, onshore wind and solar is actually cheaper than gasoline and like fossil fuels in terms of renewable energy, which is amazing. And it's great to see how far we've come in that respect. And so what is actually one of the biggest sticking points for being able to achieve 100% renewable is the fact that wind and solar are not active 24/7. So one of the key concerns nowadays is we actually need a significant amount of energy storage, and we need to be able to store that energy for a long amount of time. And so developing the grid in this way is going to require a lot more energy storage, and lithium-ion batteries are one of the main ways people are looking into trying to address these needs. So now we have some of the why do we care about lithium-ion batteries. I just wanted to quickly cover like what do we mean by a lithium-ion battery, right? So lithium-ion batteries are, we'll start with the term lithium-ion. So lithium is a type of atom, and in case you may or may not have learned or remember at this point, atoms consist of three things. So protons, neutrons, and electrons. So here, the schematic basically shows what an atom sort of looks like. They're the building block of a lot of things, basically everything in the universe. And so the nucleus here is made up of protons and neutrons, and then the electrons sort of orbit around that center. And one of the key things to notice is that we assign electrons to have what we call a negative charge and protons to be a positively charged. And this is important because in terms of talking about ions, because ions are basically just atoms that have actually lost one of their electrons. So lithium here has 3 protons and 3 electrons. And so when we refer to a lithium ion, it just means that it's lost an electron. So then we give it this plus sign to indicate that there are now more, there's one less electron. So it's effectively positively charged. And charge is a concept that is related pretty closely to energy, because basically the way the physics works is that charges move due to what we call basically a voltage, right? You've heard of like voltage probably if you've like looked at like your light bulbs or something, like power outlets are like 120 volts or something like that. And charges basically, if they move through a voltage, will gain energy. And so the energy is just the charge of whatever is moving times the voltage it moves over. And so what you can think of electricity is basically just electrons moving. And because they move, they have this energy that they lose. And that's how we sort of power everything, is just by manipulating electrons to move around. And so this is very important for lithium-ion batteries because, well, that's basically what they do, is they manipulate charges to move things around and create energy. So this is just a basic schematic of what a lithium-ion battery might look like a bit. There's a positive end and a negative end. If you've ever used like one of those like batteries, we call for like small devices, you'll notice you have to match up like positive to positive and negative to negative. And then basically lithium-ion batteries work by just having the lithium, which is charged, move from one side of the battery to another, one side, the negative end to the positive end if you're discharging the battery. And then that basically gives you energy as it causes electrons to move consequently. And then if you're charging a battery, it would go in reverse. So lithium would actually move from the positive end to the negative end. And so the lithium in this way sort of acts as like a reserve of power. Yeah, so that's sort of the basics of lithium-ion batteries and their science. And I just wanted to quickly stop for a second and ask if there are any questions at this point.
Yeah, and what is this separator that you show there? What is that? What kind of material is that, and why is that necessary?
Yeah, so let me go back to this one. This one sort of goes back a little bit easier. So the separator, one of the key things about batteries and the way they work is that they there's a little like there's like a liquid substance in between the two ends here, which contain the lithium, that allows the lithium to move back and forth. But the important thing is that it doesn't allow the electrons to move back and forth. So you can get lithium flow, but you can't get electron flow. And that's sort of what the separator is there to, is to prevent the contact between the two of them to allow electrons to flow. Because in the electrolyte, basically only the lithium ions can move. And if only the ions can move, in order for the ions to move, electrons also have to move, is one of the restrictions on like the way ions and like electrons move, is that they like quote unquote must be charge balanced, which means if you have an electron move, a lithium ion move, you have to have an electron also move. And so that basically prevents your battery from just discharging spontaneously between each other. It's actually one of the key points. You need the separator there in order to keep the energy stored. If there was no separator, all the lithium would just move from one side to another, and you would lose all the energy. And it's actually that is like one of the sources of why lithium ions can like be a little bit dangerous and why they're not allowed on planes. It's because if the separator like fails, all the energy in the battery is going to discharge at once, and that can cause like fires, things like that. And the separator is typically just made of like some sort of like fibrous like material that's just like, it doesn't allow electrons to move through, basically.
Yeah.
Isn't lithium a gas at the room temperature, or am I wrong? Or
no, lithium is actually a metal at room temperature.
metal?
It's actually a very, very reactive metal. It's actually on its own, like just pure lithium metal can be quite reactive. If you look up like videos of lithium put into water, it's actually quite explosive. So lithium, you have to be a little bit careful. That's why there are lots of restrictions on lithium ion batteries, and there are lots of safety measures put into the batteries to prevent anything like that happening.
You said something about a liquid though in the battery, right? So what is that liquid? Lithium something?
So the liquid we refer to as the electrolyte. It's a substance for which the lithium ions can like freely move through it. Basically, it's just to allow the lithium to move through from the positive end to the negative end, or vice versa. Yeah.
And how do you control the rate at which the ions move?
So the rate at which the ions move is going to depend on so if you're discharging, it's going to depend on basically what you connect to discharge. So every device, so the rate at which ions move controls the rate at which electrons move. And the rate at which electrons move is referred to as a current. So different devices will have different currents that they need, and those will be designed so that if you connect them to the battery, they will controllably take some sort of current rate. And then similarly for charging, you can sort of adjust the rate at which it charges depending on what the charger is.
So it's on demand. It has nothing to do with the separator.
Right, so let me sort of talk about, so the separator is to prevent electrons moving inside of the battery. The electrons actually, they move outside of the battery, so they go through wherever device you hook it up to. That's how it supplies energy to whatever you hook it up to. So the separator is to prevent electrons going inside of your battery, which is something you don't want, because then you're not giving energy to like the thing you hook up to it. You want it to go outside the battery to whatever you hook up to it.
Got it.
Are we all good? Yeah. So if there are no other questions, then I'm going to move on. So we've sort of covered the a basic rundown of like the science behind it. So I just want to talk about now, what are some of why are lithium ion batteries such a big deal nowadays? Like, why are they being used over other types of batteries? And it's taken, lithium ion batteries are actually fairly complicated devices to like use. There are a lot of restrictions. So that's why it's taken so long to make them. But because they've been discovered and they have been made, they have actually a very high, what we refer to as energy density. So it's the amount of energy the battery can hold per either volume, like the amount of space it takes up, or per weight. And this graph basically shows different batteries that have been used in the past that are rechargeable. So like a lead acid battery is one you'll have in your car, like a current gas vehicle, while a lithium ion has a much higher energy density, both in terms of volume and in terms of mass. Another thing that lithium ion batteries have going for it is that they, what we refer to as a voltage difference is actually like 3 times as high as these other technologies. So it's 3.6 volts versus 1.2 volts, which is good for if you want like if you want to be able to have a lot of energy. Also, these devices have what we refer to as higher power, which basically means they can discharge at a higher rate. So you can gain whatever you're hooking up to the battery can gain energy as a faster rate than these other devices, which is very useful for like a car. Because if you think about how cars move, your acceleration is basically determined by your power. So like if you want your car to go from like 0 to 60 on like the highway in a reasonable amount of time, your battery needs a high power, basically. So that was one of the like restrictions that's needed to create basically an electric vehicle. And it's also useful because it means you can also charge the car at like more reasonable rates. Because otherwise, right, that's one of the things electric vehicles, even nowadays, is like you have to wait a long time to let them charge. And that's one of the downsides they have compared to gas vehicles. Other things that they have what we refer to as lower self-discharge rate. So batteries over time, unfortunately, will slowly lose energy, just due to like just slowly like degrading over time. And so these batteries, some batteries can like degrade fairly quickly over time, but lithium ion batteries only degrade about 1.5 to 2% per month. And also lithium ion batteries, some batteries have like very specific maintenance like needs, but lithium ion batteries are a little more lenient in that respect. This next slide I have is what we refer to as a Ragone plot, but I think it's not too hard to understand what it's trying to say. So on the left side, we have what we refer to as specific energy, which is just the energy density, so it's the amount of energy that the battery can have. And the bottom is what we refer to as specific power, which is basically correlates to acceleration. So in terms of vehicles, the left side gives you basically your range, and the right side gives you what the acceleration of the car is possible. It's a little complicated, but the key thing here is to look at the lithium ion one, and you can see that it has higher specific energy than these other technologies have, and also higher specific power than most of these. And to make a good electric vehicle, you need both. So lithium ion batteries in this respect have been the best we've seen so far, though not quite at the goal you would want for electric vehicles. Good enough to make decent electric vehicles, but maybe not enough to like make very good ones, you know. And so these are all great, but lithium ion batteries also do have their downsides, and that is safety. There has been one of the key things that limits how fast like lithium ion batteries can like discharge and charge is the fact that if you're not careful, you can cause basically the lithium ion battery to we refer to as shorts, where if we go back to this original plot, so we talked a bit about the separator here, and how important it is. But if you're not careful with the way you like charge, the rate at which you charge or discharge the battery, the anode can actually, the way it like the lithium enters the anode, it can actually pierce through the separator. And if that happens, you basically lose all of your energy at once. And we refer to that as a short circuit in the battery. And that is bad because if you lose all of the energy stored in a battery at once, that's a lot of energy you're discharging at once. And so it ultimately results in like a fire hazard at that stage. And that's sort of why, you know, you have to be careful about the environments that you can put, you know, your batteries in. Nowadays, batteries have of course, have a lot of restrictions on them in terms of use, and the engineering on them is like very creative, very well done to try to minimize the safety. And of course, for engineering and for any products that are put into market, there are lots of safety restrictions that are put in. And so realistically, you probably won't see much of this if you're using a device with lithium-ion batteries, but it is a concern that, especially on like the engineering side, you have to really think about. Bob, I see you unmuted. Do you have a question?
Yeah, again, the airlines, I guess, warn you that you shouldn't be carrying any lithium batteries, I think probably in the passenger compartment. But I don't really know. I don't think they mark on any of the batteries or any of the devices that I have that have batteries, whether they are lithium ion batteries or not. How would I know?
Yeah, to know that, you would have to either take apart the device. So there's most small devices you would use to like that would have a lithium ion battery. You could of course look through like the owner's manual and it'll probably tell you. But otherwise, I think sometimes if you look on like the back of certain devices, they can tell you about the type of battery. Otherwise, there's not too many great ways, but I think nowadays it's pretty realistic to expect most phones and laptops will have a lithium ion battery in them. And so it can get a little bit iffy, and even things like electric toothbrushes can have them. It can be a little bit iffy for like toys and like other small applications to like know for sure. It's probably easiest just to look at like the bottom of it and check. A lot of times they do list off those types of safety.
So you said it would actually say whether it has a lithium ion battery in it, or
it should. There should be some sort of symbol that indicates it'll look like a little battery with like a fire on it.
A little battery with a fire on it.
Yeah.
Really?
It's one of those like graphical ways of like illustrating like a hazard. I don't have that on this presentation, otherwise I would show you what that might look like.
I've never noticed it or thought about it, actually.
It can. Lithium ion batteries are fairly safe, but if you do want to look at it, they don't make it as easy as they probably should to know. But Linda, hi.
Yeah, hi. Yeah, I had a question. How are they working on that for cars? You know, the fact that it could possibly catch fire. Are they going to be working on that pretty hard?
Of course. I mean, of course, any car that goes on market has a lot of rigorous like restrictions made onto it. Cars, as far as I know, haven't had this issue. Like earlier versions of lithium-ion batteries definitely have had this issue, but I think the technology is developed enough that it's not a huge concern. And I know this graphic is a little concerning, but also these are all early versions of lithium-ion batteries, right?
Okay.
This is 2012, 2013, 2015. Modern vehicles should have pretty high safety standards. I don't have the statistics off the top of my head about like what that would look like, but these usually are not a huge concern. And also notice that these mechanical abuses here are like from like major car crashes.
Okay.
You're probably not in a good place if that happened anyway.
Yeah.
Yeah.
Okay, thanks.
Yeah, for most everyday use of like a vehicle or like a device you're carrying, these types of hazards shouldn't really come into play. Something in chat.
Oh,
I
that
have
was
a
just
friend-
me. I
oh,
have
yeah.
a close friend whose EV model was recalled specifically for spontaneous
Oh,
fires.
actually, yeah, now that you mentioned, I have heard stuff like that. Yeah, it's not infallible. It might
Yeah.
be a good reason. Maybe you don't want to like consider an electric vehicle nowadays. But also, yeah, if you so like it is something to take into consideration. I mean, to be fair, for gas vehicles, you are carrying an explosive gas in your vehicle at all times. You can sort of just deal with it. But like,
Yeah, that's true.
but yeah, that there are hazards, but I think cars in general do have their hazards.
Yeah, I think
And
it
I
was
mean,
just higher profile specifically because it was an EV, right? Like people were talking about it more
yeah,
and stuff.
yeah, for sure,
Yeah.
for sure. It's a new technology, people want to know, but it's developing and it's getting, there are more models coming out, more data, more experience people have with this type of technology, and I'm sure it'll get just safer over time. And also, as we'll talk about later, more technologies are being developed that could be safer than lithium ion at some point, maybe in the farther future. Not immediate, because lithium is currently the state of the art. Is there any other questions? Or I guess I'll just move on then. So, oh, okay, there we go. Okay, so we've talked about safety. Now let's talk about one other downside with lithium, and that is price. Well, it's not maybe a strict downside because lithium is cheap enough that you can make cost-effective vehicles, like they're pretty competitive, but also we are going to need a lot of lithium if we're going to distribute like large numbers of vehicles and like devices. And because of that, just even very recently, like this is very recent, like last few months, like lithium prices have jumped quite a bit. And yep.
Where is lithium mined from as a metal? I mean,
yeah, I looked up a bit of this. A lot of it is from Australia, actually. I think like, what is it, like 30 or 40% is from Australia. There is some in China. There's a little bit in the US, and I think those are like some of the major ones, but I think Australia is like the number one.
and then
yeah,
when you said it was very reactive, how is it transported then from Australia or whatever to?
So that's just base lithium metal. But if lithium is you can get lithium in other forms. For example, there's lithium carbonate or hydroxide, which are just different like chemical compounds that have lithium in them that you could use, and then that are not quite as reactive, that you can then transport. But these, you still have to be very careful about putting it in like air. So usually you would like vacuum seal it first so that it doesn't have like any oxygen.
People also take lithium medicine, right, for nervous conditions or something.
Yeah. So one thing to keep in mind about these compounds is, yes, they have lithium in them, but depending on how they're like, what the specific compound is, like how the lithium is bonded to it, it could be safer overall, because lithium is very reactive, but if you react it with something and like make a different compound, it can be a lot safer in that sense. But I'm not an expert in like medicine, lithium in medicine, so I'm not quite sure how to talk about like any safety, like health concerns about that. So, but it's definitely to like something maybe you could like look into. Yeah.
So you're saying that the lithium is transported from Australia, for example, as one of these compounds?
Usually, yeah. Usually when people talk about prices of lithium, it seems like they talk about it as like bonded with like a carbon or bonded with like what we refer to as hydroxide. Like, so they've already reacted, so they're not as dangerous. Linda?
Yeah, Peter, I was just going to ask, I heard a report on TV a few weeks ago about lithium, how they do import most of it right now, and that there's places in the Southwest of the United States they're planning to start mining, with the cars coming online. They said 20 years from now, it'll be, crazy a lot that they need. What are your thoughts about, how's that going to be? Because they're going to be mining a lot of places. It reminds me of how they, drill for oil all over. Is that going to be okay, do you think, for the environment and everything?
Yeah, that's a great question. I don't know much about the specific mining procedures done, like the safety, how safe the mining for lithium is done. I assume it's similar to mining like other metals, in terms of safety, which that's sort of,
Right.
I mean, how safe do you think mining for coal is versus like, drilling for oil and the like environmental concerns? Oil, right? If you drill for oil, there are a lot of environmental concerns in the state in terms of like natural habitats and like wildlife. So like mining in that sense won't affect those types of regions. But I guess I'm not a huge expert in terms of what the long-term.
Yeah, it was a pretty good report there. Just a few weeks ago, I saw it on some news station, I think, made you concerned about it,
No, that's totally a valid concern. So yeah, we need a lot of resources, and knowing where they come from and like how we're getting them is definitely an important consideration. And yeah, lithium is a fairly rare metal. I think I saw a statistic at one point that said if we wanted to use lithium to like for like our power grid, like there just isn't enough lithium on Earth to do that.
Wow.
So
Mhm.
like if you like measure like the amount of lithium like in the Earth's crust, there just isn't enough.
Wow.
So
Yeah.
to go full lithium would be very difficult, and that's why people are also looking into other technologies at this point.
Other things.
So we have to go off Earth to get to mine the lithium. Is that what you're saying?
I think that might not be very cost efficient, I must say. But as I'll show later, people are looking into using other elements as well. So the reason why we use lithium is because it's light and it's small, as an ion. It only has 3
Right.
electrons. But you could theoretically use something like a different element, like magnesium or calcium or even just sodium. And I mean,
Sodium is very highly reactive.
well, that's true, but also sodium, I mean, you eat table salt every day and NaCl, sodium chloride. So again, if you can get it reacted, it can be okay.
So there's an idea, start making sodium powered cars.
Yeah, that's definitely
Table salt.
salt powered. Yeah, it's definitely funny to think about.
Or hydrogen batteries, which of course people have
hydrogen fuel cells.
Yes.
I have worked on systems that were more modeled on hydrogen fuel cells. There's the reason why hydrogen fuel cells didn't take off is a few reasons, but I think one of the main ones is hydrogen is hard to transport. It's reactive, so like transporting, it's a gas and it's reactive. So trying to transport something like that can be very difficult. And that means like if you want like a hydrogen car, right, you need to fuel it up somewhere. And so
of course, there are compounds of hydrogen as well, like maybe with oxygen.
Yeah, I mean, H2O, water, has hydrogen in it. So that is like a way people have been thinking about. There's like, I have heard of ammonia is NH4, and you can like, you can do a reaction to like get rid of the hydrogen in those systems, to like just get hydrogen gas out of it after when you just have ammonia. That's like a safer way to like transport hydrogen efficiently, basically. But these reactions cost energy, right? Converting things back and forth between like these compounds that are safer to transport do cost energy. So it's something you have to take into consideration. It also means that at these like gas stations, you need a way of converting it right there. Meanwhile, for these like electric vehicles, you just need to be able to convert the lithium when you're building the car in the first place. Do we have any other questions?
Well, I mean, that's one of the concerns that many people have, or is the range of EV cars, because gas stations generally don't have charging stations to recharge
is
your
true.
EV
That is
car.
true.
And that's, an
I think,
issue.
yeah, that is a very valid concern. I mean, it's one of the reasons why, electric vehicles get better every year. Their ranges go up slowly. And eventually, I think the ranges will hit a point to where it won't be a huge concern. But yeah, if you're taking like long road trips, definitely you might not want an electric vehicle. Right now, I think electric vehicles are great, but only if you're expecting to use them like cars for certain applications, like certain types
But
of
then there are
trips
some
you expect.
cars that generate, right, the recharging of the lithium batteries by probably using a gasoline engine,
Are you talking about the hybrids?
certainly.
Yeah. So those ones use both an electric like lithium ion battery, but you can also run it off of gasoline. So you can do both. So it sort of makes do with both. Yeah. So nowadays, I mean, I'm not saying you should buy an electric vehicle. There's lots of reasons not to buy an electric vehicle right now, but I'm just saying that over time they will get better, and I think the market will definitely grow. As they get better, there'll be more of an incentive, and as they get cheaper as well. Also, electric vehicles have something over gasoline, which is their maintenance is actually much easier. Because gasoline vehicles have a lot of moving parts. Meanwhile, an electric vehicle basically just has the battery. So yeah, there's lots of considerations when it comes to whether or not you want to buy an electric vehicle versus a gas-powered one. Okay, so move on from here. So the next thing that I wanted to sort of address is I guess that's what I mentioned, but batteries are sort of complicated devices in the sense that there is no one size fits all battery. The design of a battery for an electric vehicle would be very different than the design of a battery for long-term storage, like grid storage. So because every application, right, you need different things from your battery. And the way batteries work, unfortunately, there's always a trade-off. So you could, if you wanted to be able to charge your car like faster, that's going to come at a cost of the capacity, or it might be harder to do because there are more safety risks. Also, how long the battery can last is also something you need to take into consideration. And so batteries, as they're designed now, there's no one battery that can sort of meet all these requirements. You sort of tailor whatever battery you make to those requirements. So for instance, like if you're trying to design one for an electric vehicle, right, you want enough power to be able to charge your car at a reasonable rate and for it to be accelerate. You want good capacity for long range, for it to last a long time. Also, you want to prioritize the safety of the vehicle. But if you wanted to design a battery for long-term grid storage, you would maybe not care that much about power, but more, and I mean, safety is still obviously a concern, but you need to really prioritize capacity and lifetime in that case, because you want whatever you put into your grid to like store energy to be able to hold a lot of energy for cost and also last a long time. And so from here, I just wanted to sort of address some of the science that's going into like trying to improve these batteries. For instance, and this basically comes down to changing out like different parts in the battery and trying different things. So for instance, this battery I'm showing here is what's referred to as a lithium sulfur, which uses different materials for what we refer to as the anode and cathode. This is supposed to have a very high theoretical capacity. You could also try to prioritize like improving the like charge or discharge rate. So for instance, my research right now is looking at battery materials that could provide higher charge and discharge rates, which is particularly important for things like cars. So like theoretically, instead of charging a car for like hours, you could charge it for like minutes instead, and you would be able to. And of course, remember, higher discharge rates can come at a cost to capacity, so it's only certain materials have that capability, and coming up with materials that can do that are difficult. So like my research right now looks at trying to create new materials that can do this and have high discharge and charge rates while also being stable for long amount of time, having capacities. And then the last thing I sort of want to address that I mentioned earlier is instead of just passing around lithium, you could consider passing around something like magnesium or calcium or sodium. And I think those are the three mainly being looked at. And all of those have their own like scientific problems. So like the research for all of them are fairly independent, but and they also have their own difficulties. But over time, they all have if we could, maybe magnesium won't be quite as good as lithium, but as long as we can diversify a bit, and not be as dependent on lithium and get good magnesium performance, probably still be okay. And this is a project that I think in the future I'll probably be shifting to, just because of what program and like what funding agency I work for and like what they're currently focusing on. Yeah, so I also wanted to quickly just mention, I have here like a quote from a research scientist from Harvard University that talks about sort of in the news, you hear a lot about like battery breakthroughs and why, and also just in general, there are lots of times you hear about breakthroughs in science that don't really seem to go anywhere, right? Like us as like consumers, we never really see products about it. And I think a lot of that just comes from like misinformation, not really misinformation, but just not a clear understanding of what those breakthroughs really mean practically. Because, for instance, this quote here I have from Shinli, a professor from Harvard University, talks about how a lot of times there are so many battery breakthroughs, but the issue is sometimes those breakthroughs, while they help a specific battery technology, like you could be improving lithium sulfur batteries a ton, that doesn't make them as good as the modern day lithium ion batteries that we currently have in cars. It just means that they're getting closer to reaching that performance and then maybe someday exceeding it. And a lot of times science isn't like one big breakthrough at a time. For instance, here I have a quote by the co-founder of Tesla, who talks about how when they started Tesla in 2003, they saw steady increases in capacity of the batteries for about 7 to 8% every year. And since then, that's all they've really ever done, right? A slow 7 to 8% improvement every year. And over 19 years, it's all just in these little steps. And so a lot of times in science, where you're going, while the news will talk about these huge breakthroughs, it might be good to consider the broader context of what those breakthroughs means. Because a lot of times in science, what really is happening is things at the state of the art slowly progress and get better slowly over time. It's very rare for huge breakthroughs to actually come through. They do happen, but it's not always. Science is a process that takes time, unfortunately, even though sometimes we don't have enough time for that. Okay. I added this part in last second, so I'm not an expert on recycling, but I thought it would be nice to talk about how lithium-ion batteries are recycled. There's a lot of parts to lithium-ion batteries. You can see there's a lot of steps to this recycling process. You have to shred up the battery, you have to recover the electrolyte, you have to separate the different parts, you have to remove some of the aspects of it that you don't really care about recycling because it's just carbon, or this PVDF is just some sort of binder that it's not hazardous or anything, but it's just used to keep the battery intact. And then you can finally recycle lithium and like start doing this all again. And then as an added thing, I just wanted to quickly mention like some of the resources Evanston has in terms of recycling batteries. I just took this off of like the website that Evanston's own website, as well as Swansea C, which I forget what that acronym stands for, but it's like it's an organization that helps with recycling in like Cook County. And so there's just a quick breakdown of like some of the information about, if you're trying to dispose of a battery, like I've done this before. I'm like, I'm not quite sure what to do with it. So they say that alkaline batteries, so like those are double A's, triple A's, or like those types of batteries can be like, you can just throw them in the trash. They're pretty safe for that. But lithium batteries and any rechargeable batteries. So this is when you're talking about like, I don't know if my battery is lithium or not, sometimes you might need to check. If it's rechargeable, it's probably lithium, is one thing to keep in mind. There's a very good chance it's lithium if you can recharge it. So they say that you should recycle lithium-ion batteries. They have some details about how what you should do with them before you try to dispose of them. You could throw them in the trash, but if you do want to throw them in the trash, you should put them in like something, in like a plastic bag, and then like tape the ends so that you can't basically short the battery by because if two pieces of metal hit like the two ends, you can actually, that can be a bit of a hazard there. So that's why they say to tape it. While Evanston itself doesn't do lithium ion recycling, they do partner with like retail stores like Best Buy, Home Depot, and Lowe's, which do take in lithium batteries and rechargeable batteries, but not the alkaline ones, which are like double or triple A. And also a little detail I saw that you can actually drop off other electronics like computers and cell phones if you want to recycle those at the Levy Center itself. So, yeah. And then just as the last sort of thing, I just want to reiterate, lithium-ion batteries nowadays are pretty much everywhere. Most people have a phone at this point. Pretty much every smartphone has a lithium-ion battery in it. Again, medical devices, laptops, cameras, toothbrushes, most like things that can recharge at this point are probably done with lithium-ion batteries because they just have superior like capacity and like price to like older technologies. So yeah, and with that, that's all I had for today. And then just like to thank you all for having me.
Thank you.
Great job,
Thank you.
Patrick.
Thank you.
Yeah, thank you.
Are there any questions before we wrap up for today? I know we got a chance to ask a lot of them during, but. All right, Patrick, you did such a good job. No questions.